Welcome my dear students to the part 3 of today's session. In this module, let us discuss about damped simple harmonic motion and forced oscillations and resonance. Now let us first see what are damped motions. Damped SHM is stated as a motion in which the amplitude of the oscillating body reduces and eventually comes to rest in its mean position. The causes of this damping are dissipative forces such as frictional force, viscous force, etc. Now consider a pendulum which is oscillating. After some time, we can observe that its displacement starts decreasing and finally it comes to rest. This implies that there is some resistive force which opposes the motion of the pendulum. This type of SHM is known as damped SHM. Now let us see what are free oscillations and forced oscillations. In free oscillations, the amplitude and time period remain constant and it does not change. This means that there is no damping. But in the real scenario, there is no system which has constant amplitude and time period. Forced oscillations are those in which if we apply some external force to keep the oscillations continue, then they can be called as forced oscillations. In forced oscillations, the system oscillates not with the natural frequency, but it will oscillate with the external applied frequency. Example of forced oscillations is that when a child in a garden swing periodically presses his feet against the ground, or if someone else is periodically giving the child a push, it will maintain those oscillations. And such oscillations are forced oscillations. Now let us see what is meant by resonance. The phenomenon of increase in amplitude when the driving force is close to the natural frequency of the oscillator is called resonance. That is, if an external force with an angular frequency omega d acts on an oscillating system with natural angular frequency omega, then the system starts oscillating with an angular frequency omega d. The amplitude of oscillations is the greatest when omega d is equivalent to omega. This condition is known as resonance. Swings are very good example to prove the property of resonance. So resonant oscillations are those in which when an external force is applied on a body whose frequency is an integral multiple of the natural frequency of the body, then its amplitude of oscillation increases and these oscillations are called resonant oscillations. Now let us see an example to explain the concept of resonance. In the above figure, you can see 5 sets of pendulums of different lengths suspended from a common rope. The figure has 4 pendulums and the strings to which pendulum bobs 1 and 4 are attached are of the same length and the others are of different lengths. Once displaced, the energy from this pendulum gets transferred to the other pendulums through the connecting rope and they also start oscillating. The driving force is provided through the connecting rope and the frequency of this force is the same as that of pendulum 1. Once pendulum 1 is displaced, pendulums 2, 3 and 5 start oscillating with their natural frequencies with different amplitudes, but this motion is gradually damped and not sustained. Their oscillation frequencies slowly change and later start oscillating with the frequency as that of pendulum 1. That is the frequency of driving force but with different amplitudes. That is, they oscillate with smaller amplitudes. The oscillation frequency of pendulum 4 is different from others. This pendulum, which has the same length as that of pendulum 1, starts oscillating with the same frequency as that of pendulum 1, and its amplitude gradually picks up and becomes very large. This happens due to the condition for resonance getting satisfied. That is, the natural frequency of the system coincides with that of the driving force. Hope you have got an idea about damped simple harmonic motion and also the concept of forced oscillations and resonance. Thank you, dear children.